year before last, and what they do in the community is truly amazing. They really bring more than they take, and to me, that's the indicator of a good friend, a good community. When you take more than you bring, that's bad. These people, they want for their friends, not from them friends. They want for their community, not from their community, and I have the highest respect for the Carl Hayden team and anyone that's affiliated with them.
Well, the school's had a fantastic experience with these kind of competitions. It was the first, and after about the third year, they were going, look what this is doing to the kids. I mean, look, kids are going into college. Not only are they going to college, they're going into engineering. Not only do they go into engineering, they're graduating as engineers in 4 years instead of, I think the mortality rate's over 50% of kids that go into engineering.
Are you reckoning because that took 6 years to graduate from college?
No, 6 years is fine. If it takes you 6 years, what counts as graduate? Half the kids that go into engineering never graduate from engineering.
As a matter of fact, that's 2/3, at least in the Bay Area, that don't complete, only 1/3. Yeah. They say when you sit down in engineering school, you look to your right, you look to your left. You said those people will not be there when you graduate.
Yeah, and you hope the other ones aren't looking at you.
Well, yeah,
but anyway, it was a fantastic thing. Then we went to an underwater competition, and the kids did fantastic. Matter of fact, they beat the universities, and that was the big news, that they beat MIT. And we went, we've got to get the kids involved in these kind of competitions. It's like lighting a fire. They want more and more. For the fourth year, we couldn't go to that competition anymore, so that's when this one started. We decided, why isn't there one locally? You don't need an ocean to do underwater robotics. And that grew. This last year, they did the Steve Conrad Aerospace Award thing.
Yes.
They had to, they entered a competition that was designed something that they could use, an invention that they could use in space. And they took the idea of the underwater robot, take away propellers, put on thrusters, get rid of the tether, use remote control, and throw the camera on it. And why don't you use that to fly around the shuttle to look at tiles?
And how did they do? How did they do? What did they win?
Well, they made it through the first one. They were one of 6 or 7 finalists and went out to Palo Alto, the Ames Space Research, and they won the whole thing.
Right. I got an opportunity to meet with them out there. We gave them a little tour of Ames, and I think during that time they were so smart. They're taking it all in they're sucking it up like plants. They're just taking it all in, and they came up with some great ideas. NASA was really impressed with their ideas, and I know that the review panel thought these kids they're something special. They got a chance at changing the future. And I was at the time I was working in another area, so I didn't get to go hear their papers, but I heard they really blew the socks off the judges.
Hey, British Petroleum, the website is www.h2robots.org. Give us a call. Maybe we can help you.
Oh. Wow. Oh, well.
No, there's a lot of talent in this room tonight.
Poor adults.
This is what makes the difference.
The thing is, these kids are smarter. And they probably have the same IQ as some of the smart people that we went to school with, but because of where they're learning and how they're learning much younger, they're coming out with a lot more brain power and brain capabilities. So we have very high expectations of what they will do and how they'll solve problems like the problem in the Gulf right now. We think that in 20 years from now, they would already have this problem solved. And I believe that they won't deal with bureaucracy in quite the same way, because I've seen these kids break some of the rules of technology and actually succeed. So I assume they'll continue to do so.
It's sort of odd that you do work with. I mean, what do we in the desert know about underwater robotics? But that's one of the advantages. If you don't know, you can't do stuff, and you give it a try, and then it works.
Exactly.
I know it's worked for us a few times. Things that people knew. I mean, they never tried it because they knew it wouldn't work.
I got to say something about this. So these students here, they don't know what they can't do. You said it yourself.
Yeah.
The reasons NASA works with students like this, building the lunar micro rover, is they don't know that they can't do it. They don't know about thermal failure. They don't know that they don't know that Einstein was right. I mean, I don't think you go faster than light drive, but some of these kids might just come up with something that exceeds the speed of light. Much like Mr. Yeager when he broke the sound barrier, people really believed that it could not be done.
Yeah.
I am in my old ways of thinking. I don't think you can go faster than light, but that's my problem. They don't know that. They'll probably solve it in ways that we never thought of. Or die doing the math.
That was one of the fun things about walking around the pits. Here we all have the same problem, same game, and the variation in the ROVs was fantastic. They were all over the place. So we'll see how that goes. So here's the light from the Nerds ROV. It looks like they're going down near the bottom, if not on the bottom, and coming up on one of the structures that should be one of the bait platforms. On the right side of our screen, you see little wavy things. That's simulating seaweed and kelp. The structure on the right side, that's the Nessie nest. And up on the top in the center is where the egg is. The Nessie egg is a round ball about the size of a volleyball, and it's filled with water and a little weight, so it's a little negatively buoyant and has a glow stick in the middle of it so you can see it.
You must be below him. Okay, great. Okay, you're up against the wall.
Designers of the game kind of thought that might be a little difficult to manipulate. It's
Yeah, we need to see the bottom.
it's not solid enough where you'd pinch it to grab it. It's large enough that you're not going to be able to like hold it in the palm of your hand and swim away with it. So
Okay. Yeah, you should be able to find us. That would be great. And then lead us to. Oh, that's the nest. Okay, so we are. So that is the nest.
I've got no clue where I'm at.
once again, we do this competition at night for two reasons. One, we're trying to simulate what it would be like to be under the ocean, and except for the first 50 feet or so, it gets dark real quick, so you have to worry about lighting. Use one camera, which most of us use. You have a depth perception problem. When you come up on something, you'll see quite often they'll overrun it. Part of it is because it's hard to control, but second, you don't realize how close it is because it's like driving with one eye. The other reason is this is Arizona and it's June, and not a lot of us want to be out poolside. And especially the judges, they don't. Although today we were blessed with some pretty good weather. It was, I think it only got up in the 90s and cooled off rather quickly, and we had some wind. Okay, it looks like they have the bait canister. The bait canister is a little negatively buoyant, so there is a weight problem. You have to have, your motors have to be strong enough to be able to maneuver your ROV, plus the extra weight of the canister. And on the smaller ROVs, that might be a problem. So, but that is a good shot. You really get.
Did you follow the lines?
Yeah, because we just left one.
Okay.
Don't ditch me.
Okay, turn to your left.
Hey!
And I think our point of view is away from the edge of the pool where they launch it. Those stripes on the bottom start at the edge of where they launch and move out to the pool. So the diver looks like he's in a shallower end of the pool.
Every time you say launch, I'm thinking about food, like lunch, launch. Listen, just a point of clarity here. The maximum number of points that any team can get is 270 points. So the typewriter pyramid did get the maximum number of points. It turns out that there's a third category of points which you can get either or. You can either get 5 points for finding the nest egg, or they can get 5 points for correctly reading and converting the temperature binary. They can get 10 points for controlled move of the egg, or they can get 10 points for the accurate reading of the temperature. So they can get a total of, in that area category, you can get maximum 15 points. Once they get the 15 points, even if they get the others, they don't get any more. So the maximum score is 270 points.
And that's what they got, wasn't it?
They got the maximum.
All right.
They got the solar maximum. Happens once every 11 years.
Yeah. Speaking of radio waves, when it's at the maximum, that's when you get the greatest shortwave reception and transmission. When it's at the minimum, it sucks.
Isn't that amazing?
Yeah.
So Maria, what are they doing right now? I think that we know, but could you just clarify for us, please?
I think they're trying to focus on looking for the stuff because they're running out of time, and just by locating stuff and pointing it out to the scorekeeper, you get points. It's not that many points, but it's still